Alright, for this morning, you guys will need a textbook, if you didn't pick one up on the way in, calculator, and a new fresh piece of paper. So you go ahead and get that out and then number the handout as 94. Give you a second to get caught up there. Okay, so we are moving into our last and final section over logarithms, section 3.4. So I've been mentioning for a while that 3.4 is all about solving equations. So some of the stuff we've already reviewed is going to help us out, but there's a few things we haven't seen, and we need to tie them all together as well. Alright, so today's is going to make up number 94. Now, being able to solve these equations is certainly good, and logarithms and logarithmic properties and all that stuff certainly will help you in science courses at some point, if not already, depending on what science you're in. But honestly, in mathematics, the reason we need to know these log properties is for solving equations. That's really the end goal that we're hoping for our purposes. So this is kind of what we've been building up to. So question one, what makes logarithms unique? What makes them special? Well, what they can do that other algebra cannot do is solve exponential equations. So if you have a variable stuck in the exponent that you're trying to solve for, no matter how creative you are, your other algebra skills are not going to be quite enough. You need logarithms for that. Now, in our notes here, I kind of start off as basic as I can, and then I kind of build you up towards what the book assignment is going to build you up towards. So the easiest of these, and there will be a couple questions like this in your assignment, is some of these you can just do in your head, hopefully. I think you should know that 5 squared gives you 25, 2 to the 4th gives you 16, and even if you have to read a logarithm, as long as it's a nice whole number like this should also just be something you do in your head. 2 to the 3rd gives you 8, 3 squared gives you 9. So not all equations that we solve with logarithms are going to be difficult. So if you can do it in your head like those, then of course do that, because that would be the quickest and most efficient. Okay, and then one of the most common ways to solve these equations is switching from exponential form to logarithmic form, and then in just a moment logarithmic form back to exponential form. So we've already talked about how to do this, and you have had to do this once or twice I think at this point, but there'll be a lot of this today. So if something's in exponential form, consider switching it to logarithmic form. Remember, all that means is you put log out front, and then you have to know which two things to switch. And then if you know what x equals, then it's solved. So that's all you had to do. Logarithm or exponential form, switch to logarithmic form. Since it says x equals, it has been solved. Exponential form, equivalent logarithmic form, x equals, so it has been solved. So you'll have a few questions that will be that straightforward as well. All you have to do is switch it from exponential form to logarithmic form, and then you can be finished. Now this over here, these three questions are the same questions, so I want you to see that we get the same answer. But this is one of the more advanced skills, and you don't need this most of the time, and I don't think this is easier than what we just did on these three, but some questions this is going to be necessary, so I need you to know that this is a potential strategy. Sometimes what you want to do is take the log or natural log of both sides, and you can do either the log of both sides or the natural log of both sides. Now in this case, if you did that, that's okay to do because it keeps our equation balanced. But then from this property of logarithms, an exponent on something you're taking the log of can be brought down out front. Natural log of e is just 1 because it's the same e to what power gives you e. So you still end up with the natural log of 5, which is what we got doing it the other way. So it's not like you have to work this question in this way, but this is a needed strategy sometimes. Sometimes taking the natural log of both sides is the only way to move forward. And or if you'd rather take the log of both sides, that's okay too. I took the natural log here because this was an e, and I'm doing a common log here because this is a 10. It just makes it look a little bit nicer, but either one is fine. Exponent on something you're taking the log of can be brought down out front. If there's no base here, it's an understood base 10. Log base 10 of 10 would be 1. So you end up with an answer of log of 3. Same thing that we got doing it the other way. Okay, one more. So again, I'm not saying you have to do it on this question, but sometime when all the other things we talked about on this handout don't work, yeah, let's just do log, doesn't matter. Sometimes the only way to get started is doing this. Take the log of both sides or the natural log of both sides, whichever you prefer. Then the thing you're solving for is an exponent on a logarithm, so that can come down out front. And then you can undo times with divide. Now, I guess my question would be, is this answer to number 11, is this the same thing as the answer to number 8? Okay, and how do you know those are the same thing? Right. If you know the change of base formula, then you know that these two are equivalent. So it doesn't matter that they look different, they are saying the same thing. And that's really the need for the calculator here in a bit. Because there will be some book assignment questions you guys do that are odd. Your answer will be right, but it may not look the same as the back of the book. Your answer may look like this, theirs may look like this. And in this case, I would hope you would know that's just change of base, but sometimes it's not going to be as obvious. So I'm going to show you how to check your answers with a calculator. So again, this is at pretty much the bottom of my list, but when I know nothing else to do, consider taking the log or the natural log of both sides. Sometimes that is the key to moving forward. Alright, so if switching from exponential form to logarithmic form sometimes solves the equation, the next four are going to be the other way. If it is logarithmic form, you might consider switching it to exponential form, especially if it leaves you x equals, because then it has been solved. Natural log means log base e. Switch it from logarithmic form to exponential form, and it's solved. Switch it from logarithmic form to exponential form, and then one step later it's solved. Switch it from logarithmic form to exponential form, and then it's been solved. If you can switch forms quickly, then some of the questions would be very quick like that. Okay, are you guys okay with those four? You know where this e is coming from? Okay. Alright, so let's keep a running tally of the things we've talked about. Sometimes they're easy enough to do in our head, so that's the quickest and easiest. Of course, that's not going to come up that often. If it's in exponential form, switch it to logarithmic form. If it's logarithmic form, switch it to exponential form. And then if nothing else works, maybe take the log of both sides. Okay, so adding on to that now, as I said, it's going to build up in difficulty, just like the book assignment will. But these are all ready to be switched. 16 and 19 are in logarithmic form, and if I switched it to exponential form, this one looks like this, and this one looks like that. But unlike the previous questions where we knew what x equals and we were done, these are just going to take a little bit more work because we're going to have to undo some basic algebra or undo some arithmetic. So this guy still needs to undo a -1 and undo a times 2 before we get the answer. And this one needs undoing a +7 with the -7. So sometimes you're going to switch the form and you still have to undo that arithmetic. Likewise, if we started an exponential form and switched it to logarithmic form, sometimes you need one more step. In this case, multiply both sides by -1. Exponential form, equivalent logarithmic form. I don't know what x equals, I know what 3x equals, so we need to divide both sides by 3 before we get our answer. So sometimes you still need to undo arithmetic after switching the forms, whether it's exponential to logarithmic or logarithmic to exponential. Or that basic algebra, basic arithmetic needs to be undone at the start of the question. So 20 through 23, these are not set up in a form where you can switch them yet. They don't match the structure that it needs to be. These are not quite exponential form, these are not quite logarithmic form because they have some other stuff. So sometimes you just want to undo the +9 first, undo the ×2 first, undo the +5 first, undo the ×7 first, and then it's in the format that we're familiar with. Then you can switch the forms to be finished, switch the forms to finish, switch the forms to finish, and switch the forms to finish. So undoing arithmetic at the end of the question, like 16 through 19, or undoing some arithmetic at the start of the question, like 20 through 23. But both of those methods still leaned on us switching the forms. You're going to get sick of me saying that, but that's the most important part. Now, some of the harder questions are going to be a combination of those two things. Again, we're building up here. Sometimes, before you can switch the forms, you need to undo some basic arithmetic, some basic algebra, like undo ×2, undo ×4, just so you can switch the forms. But still, if you don't know what x equals, then you're not finished. So just because I undid a ×2 and a ×4 at the beginning, at the end of this question, I still need to undo a ×3 and undo a ×5. So there could be arithmetic to be undone at the start and at the end, with switching the forms sandwiched in between. Now, I've been writing it like this, but again, I'm going to show you with your calculator how you guys can check in case your answer doesn't look the same. But just so you know, in mathematics, there's nothing wrong with saying log base e, but if you say that outside of this class, people are going to think that you don't know what you're talking about. Log base e is natural log. Everyone's going to just call it natural log. So it's not wrong. I'm not going to take off points or anything, but you should probably get in the habit of just saying natural log. Okay, so most important thing we talked about on the front page was switching forms. Sometimes algebra at the beginning, sometimes algebra at the end. If we're lucky, it's one we can do in our head, like questions 2 through 5. And then worst case, when you don't know anything else to try taking the log of both sides. Okay, so on to the back page. Occasionally, we need to do expanding or condensing, which is what we learned last class in section 3.3. So fortunately or unfortunately, I guess just based on your opinions here, we will not get to this half of the test before spring break. So that means when we come back, we'll have to review a day and then take this half of the test. But that test will certainly have a question or two, just seeing if you can expand or condense. But for the most part, that's really just a skill to help us solve these equations. This is a different type of equation. Nothing we did on the front page is going to help you with this. You can't do this in your head. There's no basic arithmetic to be undone. We can't switch the form yet because it's not in the right structure. We can't just take the log of both sides. you have to say, I could push these two log base 2's together with multiplication, because adding condenses into multiplication. And then after you make it look a little bit different, once you push these two into a single log statement, now you can switch the forms and solve. But if you don't consider condensing, then there's really nothing else you can do to get going. You have to consider that sometimes. The only other way to condense other than adding changing to multiplication was subtraction changing to division. So if you thought to condense those because nothing else works, then you could switch the forms and then multiply both sides by 3. Now, I don't expect you to know what 7 to the 7th power is without a calculator. That's going to be really big, so just leave it as is. Okay, once again, nothing else you could do, nothing we did on the front page helps you get this started. But if we condense this correctly, it is set up in a format that it will finish like questions on the front page. Logarithmic form and his exponential form. E to the 28th over 7 is what would make that a true statement. And then I don't know why 29's on there. That doesn't fit that format, so we don't need to do that one. So again, not a common question type. You're certainly not going to do 10 of these in the book assignment, but there'll be a couple. So when nothing else works, if it would expand or condense, you need to consider that as a way to get started. Okay, back in section 3.2, we did solve equations a couple ways, so those are still fair game. This is certainly not going to be the highlight of this unit, but if you've got some log base 2 stuff here and some log base 2 stuff here, then we just need to make sure that the stuff, the inside of what you're taking the log of is the same. And then of course you need to plug it in and make sure that it's not extraneous. But we've done questions like those before. And or sometimes you need to evaluate logarithms. So knowing that all of this just equals 8 from your log properties is really the way to move forward there. So this is where it certainly helps if you put a lot of time and effort into 3.2. It makes those very easy questions. All right, and then finally the last of the new things you need to be keeping an eye on. So at the bottom of our page here, I do have all of the things typed up the way I think you should structure it in your head, but I'm also just thinking the format of our notes here. I certainly can't do this question in my head. I can't switch the forms. There's no basic arithmetic to be undone. I can't just expand or condense, and I can't just take the log of both sides. So this one is unique. If you've got 3 terms like this, at some point, once you realize nothing else works, you have to consider factoring. So if you need to slow down and do product sum, that's fine. If you want to do guess and check and be careful, that's fine too. But you have to be able to factor. So e to the x times e to the x gives me e to the 2x. Negative 4 times negative 1 gives me positive 4. And when I FOIL the outer and combine it with the inner, it combines to minus 5 e to the x. You don't have to factor as quickly as I do, but you have to be able to factor correctly. Then you could set this equal to 0 and solve, and this equal to 0 and solve. I'm just going to add the 4 over and add the 1 over. Switch the forms, one answer, switch the forms, and technically this simplifies, so we should just call that 0. So again, pretty rare question, but when you see one that's formatted that way, you have to consider factoring it. Okay, and I think that's it for all of the techniques that you need to think about. So I want to show you one real life type question of where you would maybe need to solve an exponential function instead of just doing it, and talk about how to check our answers with the calculator, since your answers can be correct but may not look the same as the back of the book, or may not look the same as my solution videos online. Okay, so in question 32, this is one brings up a compounding, interest compounding formula. This one is the continuously one, which we called PERT. So we know how much we're starting with, 2,000. We've got the rate that the bank gives us, 2%, which has to be entered in as a decimal. But what is different about this than what we saw in 3.2 is in 3.2 we would have told you how much time it's going to be, and then you either pick that as a multiple choice answer or you threw this in the calculator and got the amount. What's different now is we can know the amount and not the time, which honestly in the real grand scheme of things, unless you're doing stuff for a company or something, this is probably how you would use logarithmic functions. You know how much money you have, you know what the bank would offer you, you have an idea of what you're trying to save up for, how much money you're trying to save up for. And so if you had no other variables, if you didn't contribute to this, we have an equation where we can figure out exactly how long it would take us for that to grow to $6,000. So, like we did on the front page, we could undo any basic arithmetic to start off. This is completely optional, but you guys tend to do a better job if this is on the left. But switch the form. It's currently in exponential form. That would be its equivalent logarithmic form. And then finally undo timesing 0.02 by dividing by 0.02. So that's not just a good estimate of how long you would have to wait, it's the exact amount of time you'd have to wait. Now, this made up example of buying a car, you probably don't care exactly to the minute how long you would have to wait. But if someday you have a math or science type degree and you get a job based on that, that company is going to be paying you money to be as efficient as possible. So they're going to want you to be able to do exact values like this, so you could get it at least accurate within 8 or 9 decimal places. Also, it's good for you to see if this is really your plan for buying a car. It's going to take you 55 years, so you might need to figure out another plan. Save up some more money, do something, because if that's your only plan, then 55 years is a long time to wait. But again, all I did was undo multiplication at the start of the question. I undid multiplication at the end of the question. But the big key here was getting that variable out of the exponent by switching the forms. Exponential form to logarithmic form. That's really what shines here. Okay, the next part is I want you to make sure that you can check your answers. As I said, there's many ways for you to get a correct answer, and your answer may be correct but look different than everybody else's. So I don't want you to think that you did it wrong, and I can't work every question out 5 different ways that you guys may get an answer to look. So using this as an example, I just said that natural log of 3 divided by 0.02 is what I believe the answer to be. I'm not looking at the decimal, I'm typing in the exact thing. So the store button that we've talked about a few times this year, if you click that, you can store it in for a variable. I usually just store it in for X because X has its own little button. But that question was about time, so it might make more sense to do alpha 4 to get T. Store it in for T for time. And what this was supposed to make true, this is how I can check, is it was supposed to make 2000 e to the 0.02 times T, here I'm doing T again, that's supposed to equal what? So no matter how crazy my answer looks, how different my answer looks than the back of the book, or if I work out a question, if yours stores in and gives you what it's supposed to give you, then yours is fine. Now, that's a pain for me on the test because sometimes y'all get answers that look different and then I have to investigate because there won't just be one way to write it. But that is one of the most valuable calculator things that I think you guys don't use quite enough is that store button. The other way that I used to use it a lot is even like on the ACT. Like if it's an equation to solve and you know how to solve it, sometimes it's just quicker to store answer A in, plug it in, see if it works. If it works, great, there's your answer, move on. If it doesn't, store in answer B, plug it in. If that doesn't work, store in answer C, plug it in. Sometimes that's faster than just solving the equation, even if you know how to do it. So I think that's a good thing for y'all to continue to practice. So make sure that you know about and continue using the store button. All right, and then here's the process of our notes, starting from can you just do this in your head all the way down to the factoring type of question. So those are the things that you need to consider. Okay, on your blank piece of paper, if you go ahead and just write out the whole assignment first, and then spend a few minutes trying the first 5, 6, 7 questions. The first questions are much shorter and much more to the point, so you shouldn't need too long on those. Also, this is a very long book assignment, but I don't expect you to finish this in class, nor do you need to finish it for homework before class on Wednesday. I will give you some more time in class on Wednesday, but I will be asking you to finish it on Wednesday. So the more of it you get done in class today will probably determine if you have homework Wednesday night or not. And then of course keep in mind that the last questions are probably going to be longer and therefore take more time. So go ahead and copy it down, start the first few, and then in about 10 minutes I will check in with you guys and help you clear up the things you were not sure about. And try to help you get as far as you can with the rest of the class. Any of these first few questions you guys get to, if you're not sure or you're getting stuck, don't spend too long on it. Just circle it and be ready to ask about it. It has been 10 minutes, so let me see if I can help you out with any of the first few. So, question 1, any part of that vocab. Question 2, knowing what word it was looking for. Question 3 was asking you to just check those answers to see which ones work. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All of those look like solving equations that are just one step. So if you didn't see what to do, that will at least be an easy fix. And maybe 17. So anything 1 through 17 that you'd like me to go over to help out?
Can you go to number 3?
Number 3? Sure. So in question 3, they are not asking you to solve it, although I guess you can if you want to. They're wanting you to say, hypothetically, if you worked this question out and you got 5 as an answer, do you know how to check this and see if it works? Of course, with the calculator, you could just store this, type this in, and see if it gives you 64, but we should try to do it without a calculator. So this would be 4 to the third. Is 4 to the third the same thing as 64?
Yeah.
Okay, then 5 is a solution. So you would know for sure that that works because it makes the left and the right side equal. For part B, x equals 2. If you plug that in, you would get this. Now 4 to the third would be 64, but 4 to the negative 3 would be 1 over 64. So that does not solve the original equation. So if you got x equals 2 as an answer, you should realize that it is not correct and go back and try to find your mistake. And then part C, a pretty crazy looking answer here, but we can actually simplify quite a bit of this before we plug it in. Log base 4 of 64 would just be 3. 4 to the third gives you 64. This ends up being 10 divided in half. So really, it looks a lot different, but it's the same as part A. So if you simplify that mess down to 5, it's a lot easier to see that it works. Of course, you can also plug it in. You can just straight up plug this guy in here. 2 times a half cancels out. Plus 7 minus 7 cancels out. 4 to the log base 4 of 64 ends up being 64. So you should have a couple different paths to figure out that that one works. But they're just trying to remind you at the start of this assignment that anytime you get an answer, you can plug it in and check it to see if it works. Even without a calculator, it's usually not too bad. Okay, 1 or 2 more before I get out of your way again. Okay, I will reset my timer, give you about another 10 minutes or so. But same thing, as you guys get to a question, if you don't know how to start it after 30-45 seconds, just circle it and move on. Be ready to ask about it. Don't waste too much time on any one question. And I know I usually say this with some of our assignments, but I'm going to say it again, and I think it's a little bit more important for this assignment. As you guys go through these questions, if there's something that, a property you don't think of, or a mistake that you make, or something about the question is difficult for you, I would very much recommend you guys circle those questions or highlight those questions. Write yourself a 1 or 2 sentence reminder about what mistake you made or what you didn't know out to the side. That's good practice to always do, but the reason why I think it's more important now than maybe in past units is since we're going to have spring break kind of interrupt us here. You guys are going to come back from spring break on Monday. You're going to not have thought about logarithms in like almost a week and a half, and you don't want to have to start off from square one. So if you highlight and give yourself some notes on this assignment, then you can quickly look at this and you will catch yourself back up a lot quicker. So do yourself a favor and do that little bit of extra work.
Final testing roster according to AP Classroom. Like there's a couple that, you know,
Yeah,
on
he
it
moved
has-
the Alps.
Yeah, he's
Okay.
just still showing in Classroom. I just
Okay.
want you to know. But if you'll just check that
Okay.
and any changes, note on there and get it back to Kincaid either today
Okay.
or tomorrow.
Okay.
Wednesday's when I got it finalized.
Okay, no problem.
Thank you, sir.
Yep. Right, it's already been another 10 minutes. Is there a few more that you guys have tried that you need help with? Number what? 40? 20. Okay. Okay, so for question 20, you need to notice that both sides are already have a base of e, so that part's already equal. So you just need to make sure that the exponents are also the same. So set the exponents equal to each other, and then because this is a quadratic, you should put everything on one side set equal to 0. Because it's a quadratic, you should probably try to factor it, but not everything factors. So this comes up only once or twice today, but it is necessary sometimes. If you need to solve a quadratic and it doesn't factor, your only option, the only way that always works, is quadratic formula. So if we plugged in -1 for b, and then -1 in for b again, 1 in for a, -1 in for c, and 1 in for a again, you end up with those two solutions. So again, quadratic formula's not going to show up all the time, but if you need to solve a quadratic and it doesn't factor, then that's really your only option. So that one was at least pretty straightforward. But I would say right here at the start, that first step is definitely the most important. Understanding that this part's already equal, and that's why you just need to make sure the exponents are equal also. Okay, another one or two. Anybody else? You said 17? Okay. So 17 says approximate the point of intersection of graphs f and g. So one equation is 2 to the x. Which looks like this. And one equation is y equals 8, which looks like this. So it looks like they are at the same place and at the same time when x equals 3. So that would be kind of a visual way to solve that those being equal. The second half of the question wants you to solve it algebraically, but if you set 2x equals to 8, that's one that you don't have to get out logarithm stuff, hopefully. Hopefully you can just do that in your head. But they want you to see this connection to what it would look like visually. Okay, is that enough for that one? Okay, one more. Okay, and I'll reset our timer here and interrupt you in about another 10 minutes. let's try again here. Got a few more that you may have found.
28.
You're 28. 7 to the negative 3 minus x equals 242. Okay, so with this one's in exponential form, and if we switched it to logarithmic form, these two would switch places, which would make it look like that. And then it looks like we could maybe add the 3 over. And then multiply everything by negative 1. Okay, and then that's what I would have to assume was my answer, but that looks kind of unusual, so I'll take just a second and store it in my calculator and make sure that it does solve the original problem. So here's what I think the answer is to 28, but it's supposed to make 7 to the negative 3 minus x. It's supposed to make it 242, and it did. So then now I know for sure it's perfectly fine, even though the answer looks pretty weird. Okay, somebody else? Yeah, Michael.
26.
26. Okay, so 4 to the negative 3 times what is going to give us 0.10. Okay, so looking at this one, it looks like it's in exponential form. So if I switch these two and put it in logarithmic form, it's going to look like that. And then the last thing would be to get rid of this. So divide both sides by negative 3. And without a calculator, which will probably what'll be happening to you on the test, you'll just have to circle that and then check your arithmetic later. But for us today, again, I have no idea how the back of the book makes it look, but there's a very good chance that it makes it look different. So the only way to know for sure if that's not the case is to store it. Which I just did, and then test the original equation. 4 to the negative 3x is supposed to equal 0.10, and it does, so now I know that that's fine. Okay, 1 or 2 more? Yeah, Harvey.
Could you go up to
38.
38, please?
E to the x plus 1 equals 2 to the x plus 2. Okay, this is a good one because, like the last couple questions I worked, I needed to switch forms. I can't do that on this one, but I also can't factor it. I can't expand or condense. I can't just undo, add, subtract, multiply, or divide. My options are pretty limited here at the beginning. So this is where I said in your notes, you don't need this often, but when you need it, there's not a substitute for it. There's no creative way to get around it. And that is, consider taking the log of both sides. That keeps the equation balanced. And then because of log properties, this x plus 1 is an exponent on something that I'm taking the log of. So the x plus 1 can come down out front. And natural log of e is just 1. So x plus 1 times 1. Over here, same thing. You can bring the exponent down. And if I'm going to have to solve for x, I need to get it out of these parentheses. So I'm going to distribute the natural log of 2. Remember, natural log of 2 is just some number, just a messy looking number. And then anytime we want to solve for x values, we need to isolate x. So everything with an x needs to be on one side. Everything that's a constant needs to be on the other side. And then when you guys get to this, most of the time you guys are used to having something like 8x minus 5x, and you can quickly just say that's 3x. But in this case, it's hard for me to combine these together, but that doesn't mean that we're stuck. I've got 1x minus however much natural log of 2x is, and even though I don't know what this is as a decimal, and I don't want to get into decimals until the final answer, or not even then really, the fact that both of these have an x means you can factor that out as a GCF, and then you can undo the timesing of all of that with the dividing of all of that. So again, I really only knew that first step because nothing else worked. That's the only reason I even considered that. That's really near the very bottom of my list of things to try. And still good practice to store that in for x and see that the left side and the right side are equal. I did that last period though, so I remember this one working. Yep. Okay, let me set one more timer. We got about 22 minutes of class left, so I'll try to take your last questions in about 11-12 minutes. Yeah.
Yeah, 6 minutes
I don't know why I thought we got out at 20 after. Okay, never mind. We got 6 minutes left, so maybe try to finish up one more question. I would say if you got to around question 36, 38, that's probably going to be fine. If you're much behind that, you probably should do a couple for homework to catch up with everybody else. I will give you more class time on Wednesday, but remember the end of the assignment questions might be longer or more difficult, so they might work out a little bit slower. But you do not have to have this finished when you come to class on Wednesday. So finish up your thought, since we've only got about 5 more minutes now, and then you can start bringing back calculators and such. Thank you for letting me know. I don't know what I was thinking.